As I have said that this device, Deadweight tester, it is a calibration standard which is used for the calibration of the pressure measuring devices such as the pressure gauges. So deadweight tester, it is a calibration standard, or it is a calibrating device which uses the principle of pressure balance to calibrate the pressure measuring instruments like the pressure gauges. So here for the calibration, it uses this deadweight tester. It uses calibrated weights, and these calibrated weights, they apply a known pressure to the device which is under test, and by measuring this or by equating or balancing these pressures, it is calibrating the pressure measuring devices. So deadweight tester, it is both pressure measuring and pressure producing device, also called a calibrating device. So it uses calibrated weights to apply the known pressure to a device under test, and this type of calibration method is a very simple and cost effective calibration method. Now these deadweight testers, they are an assembly of piston and cylinder. They are a type of piston cylinder type measuring devices which consist of a piston and a cylinder, and they are known and they are the primary calibration devices which are used for the calibration of the pressure measuring device in different applications for the electronic and the mechanical instrument. Okay, so here we can say that deadweight testers, they are the calibration device which are used for calibrating electronic and the mechanical measuring instruments. They are a type of piston cylinder type measuring devices, and they are the most accurate, simple and cost effective calibration method. Okay, now let's come to the basic principle of working of these deadweight testers. The deadweight testers, they work in accordance with the principle that the pressure is equal to force per unit area. Okay, so the pressure, it acts on a known area of the piston, and then it is going to generate a force over that piston. So working principle is based on the formula that pressure is equals to force per unit area. Okay, so a known pressure is being applied on a known area of the piston, and due to that pressure the force is being generated. So pressure is generating the force, and this force, the force of this piston is then compared with the force which is applied by the calibrated weights. So first we are going to put a known weights on the dead weight tester. Then we will see that how much pressure that weight is being applied. Now that pressure, after that we are going to apply on pressure on the piston, and this pressure is again going to generate a force on the weights which are put on the dead weight tester. So force of the piston is compared with the force applied by the calibrated weights. So by the balancing of the forces we are measuring the pressure which is applied by the fluids or by the material, or we can calibrate a measuring device. Okay. Now, as these deadweight testers are used as the calibration device, so why they are used as calibration device? Because they are using high quality materials which results in small uncertainties of measurement. So they are a very accurate devices giving very small uncertainty in the measurement and also excellent long term stability. So they are popularly used as the most commonly used as the calibration device. Now, as I have said that the deadweight testers, they are a type of a piston cylinder assembly. Okay, piston cylinder type measuring device which consists of a piston and a cylinder. So the piston, they are made up of tungsten. So piston is made up of the tungsten carbide, which is usually used for its small temperature coefficient, and the cylinders, they must fit, piston and the cylinders, they must fit together with a clearance of no more than a couple of micrometers in order to create a minimum friction. Okay, piston and cylinders, they should be accurately fitted with each other so that they not have any space in between them. So in order to have minimum friction, so that the measurement errors, they can be minimized. Also this piston is rotated during the measurements so as to further minimize the friction value. So the errors which can occur due to the friction, they are minimized with the help of this piston and cylinder type of assembly used in the deadweight testers. Now why this Now, why this dead weight tester is called a dead weight tester? Okay, why the name of the instrument is like dead weight tester? So let's see the logic behind this. So in dead weight tester, what we do, we put the weight on the weight stand, and the weight which is put, it is called the reference weight. So in dead weight tester, what we do, we put the weights on the weight stand. The weight which is put on the weight stand, it is the reference weight, or we can also say that it is the pressure which we want to calibrate, or the pressure measuring device which we want to calibrate. Okay, so this is the reference weight or the reference pressure. Now after that, we apply the pressure by moving the piston. Now when the applied pressure and the reference weight or the pressure, they are equal, in that condition the reference weight will become zero, or we can say dead, and that is why it is called a dead weight tester. Okay, so first what we do, we put the reference weight on the weight stand. That reference weight is also applying some pressure on the piston. After that, we apply pressure on the piston. Okay, now when the applied pressure and the reference pressure both are equal, the reference weight will be zero, or we can say it is dead. That is why it is called a dead weight tester. Okay, now the key advantage or the main advantage of the deadweight tester is that all the hardware which is required to generate the pressure and to precisely control and measure the pressure, they are inside the instrument itself. Okay, so that all the devices or all the instruments and parts, they are contained in the device itself. So that is the main advantage, that no other subsequent devices are required for it. So the advantage of dead weight tester is that all the hardware which is required to generate the pressure and precisely control and measure it are contained in the instrument itself. Now the dead weight testers, they are used to measure the pressures up to 10,000 bar. So they can measure pressure up to 10,000 bar, giving accuracies between 0.005% and 0.1%. Although in most of the applications, the pressure, it lies in the range from 1 to 2500 bar. So this is the pressure range in which the dead weight testers, they measure the pressure values. Now let us come this was the introduction about the deadweight tester, that where it is used, why it is used as a calibrating device, and why it is called a deadweight tester. Now comes to the construction of the deadweight tester. Now the instrument deadweight tester, it consists of a chamber. This chamber is filled with oil-free impurities. Then we have a piston cylinder assembly. Which is fitted above this chamber. We have already studied that the piston is made of the tungsten carbide, and the piston cylinder, they are very closely fitted with each other. Now the top portion of the piston is attached to a platform, and this platform is used to carry the weights which are used for the balancing. Okay, so a plunger with a handle has been provided to vary the pressure of the oil which is present in the chamber, and the pressure gauge which is to be tested, or the device which we want to calibrate, that is fitted at the appropriate place. So in the construction you can see that the deadweight tester, it consists of the chamber, the piston cylinder combination, then a plunger, a platform is also there, and the pressure gauge which we want to test. Now let's see the diagram for the deadweight tester. So this is the diagram for the deadweight tester. Here you can see that it consists of the piston and the cylinder. Inside the cylinder we are having the piston which is fitted inside it, and on the piston we are having a platform over which the weights are being kept. Okay. Now this is the chamber. Okay. The piston is fitted over this chamber. In this chamber we are having an oil which is filled with which is free from the impurities, and to the other side we are having the plunger. On this plunger is attached with the handle. Now this plunger and handle, this assembly is used to apply the pressure inside this chamber. To the other end of the chamber, the valve with the test gauge, the gauge which we want to calibrate, it is being attached. Okay. Now let's see the working, that how the deadweight tester, it calibrates the gauge, the pressure gauge which is under the. So let's see the steps which are taken for calibrating the pressure gauges. By the term calibration, we means that first we are going to apply a known pressure, and according to that known pressure, we are going to measure an unknown pressure. Okay. So balancing is done between the known and the unknown pressure, and in that way, calibration of the pressure gauge is done. So calibration means that we are going to introduce a known pressure to the gauge, and after applying that known sample of pressure to the gauge, we are going to observe the response of the gauge, that whether the gauge is indicating the right amount of pressure or not. If it is not indicated, then the corrections will be made in the pressure gauge. Now let us see the steps which are taken. First step is that a known weight is put on the platform. You can see in the diagram we are having the platform over which the weights are kept. So first step is to keep a known amount of weight on this platform. Now the second step is to operate the plunger. By operating the plunger, the fluid pressure is applied on the other side of the piston. Here you can see, first we are going to put the known weight on the platform. Now second step, with the help of this handle and the plunger, we are going to apply the pressure on the oil which is present in the chamber. So we are going to apply the fluid pressure on the other side of this piston, such that until such a force is being produced so that this piston is going to float over the liquid. Okay, it is going to float over the fluid. So that much amount of force has to be applied by this plunger, or that much fluid pressure has to be applied so that this piston cylinder combination, it floats over the fluid. So until enough force is developed to lift the piston cylinder combination. And when this happens, that when the piston cylinder combination is lifted, it is going to float freely over the fluid. So when this is going to happen, that the piston weight combination is floating freely above the cylinder, under that condition, or in this condition of equilibrium, the pressure of the fluid, it is equal to the gravitational force of the weight. So when this piston and weight combination, it is floating freely, it means that the pressure which is applied in the upward direction is equal to the pressure applied in the downward direction. Now in the upward direction, we are having the fluid pressure, okay, which is applied through this plunger, and in the downward direction, we are having the gravitational force of the weight plus the friction drag. Okay, so we are going to write the equation for here. This for here, that pressure of the fluid, okay, that is the force which is applied by the fluid. We know that pressure is equals to force per unit area, so force will be equal to pressure multiplied with the area. So pressure multiplied with the area, that is the fluid force, is equal to the gravitational force of the weights plus the frictional drag, that is F. So this is the condition of the equilibrium, that force of fluid is equals to gravitational force plus the frictional drag. Now from this equation, if we find out the value of the pressure, that is P. So PA is equals to mg plus F. So A, or we can say the pressure P is equal to mg plus F divided by A. Okay, where P is the pressure, M is the mass, G is the acceleration due to gravity, F is the frictional drag, and A is the equivalent area of piston cylinder combination. So pressure is equals to mg plus F divided by A. So here from this equation we can say that pressure is caused due to the weights which are placed on the platform, and we have calculated that. Now for calibrating the pressure gauge which we are testing here, so after calculating P, okay, so first what we have done, that we have applied a known amount of weight over this dead weight tester, and we have calculated that how much pressure that known weight has generated over the in the dead weight tester. Now after calculating the P, we have released the plunger. Now the pressure gauge which we want to test, it is being connected with the dead weight tester. Now again the same amount of weight which we have placed earlier, again that same amount of weight is being placed on the platform, and for that we have already calculated the pressure. Okay, so that same amount of weight is being placed on the platform. Now due to this weight, the piston, it is going to move downwards, and it is going to exert a pressure over the fluid. Now the valve in this apparatus, it is being opened, so that the fluid pressure, it is being transmitted to the gauge. Okay, so after calculating P, plunger is being released, gauge is being connected, gauge which is to be calibrated, is connected, same known amount of weight is placed again. This weight is going to generate a pressure over the piston. So when the same amount of weight is being placed on the platform, the piston is going to move downwards and it is going to exert a pressure P on the fluid. Now the valve which is present in the apparatus, this valve is being opened so that this fluid pressure which is exerted, that will be passed to the gauge. Now this fluid pressure, it is being measured by this gauge, and the gauge is going to give us a indication or a reading of the fluid pressure. Now this fluid pressure has to be equal to the pressure which we have calculated earlier. If it is not equal, then the corrections will be made in the test gauge and the readings are made equal. So here you can see that with the help of the known amount of weight, we have kept in both the measurements, we have kept the same amount of weight, so same amount of pressure has to be generated. First pressure we have already calculated, okay, by using that formula P equals to mg plus F divided by A. By using that pressure value, we have seen that the readings of the pressure gauge in the second time should be equal to that first value which we have calculated earlier. If it is not equal, then calibrations have to be done, corrections have to be made so that the gauge give us the correct indications of the pressure. So in this way, the deadweight tester is calibrating the pressure gauges and it is used for the calibration of the pressure measuring devices. Okay, so here also you can see that when the reference weight and the fluid pressure, they are equal, the known weight is dead. That is why it is called a dead weight tester. Now if we see the applications, we have seen here that the deadweight tester, it is used for the calibration of the pressure measuring devices. If we talk about the advantages of the deadweight tester, it is very simple in construction, easy to use, can be used to calibrate a wide range of measuring devices. And the fluid pressure can also be easily varied by varying the amount of weight which is kept on the platform. If we talk about the disadvantage or the limitation of the deadweight tester, its disadvantage is that as the piston cylinder is a combination, it is moving, so due to the moving parts in the apparatus, there is a friction, and due to that friction, the accuracy of the instrument is being reduced. Okay, so these are the limitations of the deadweight tester. So here in this video, we studied about the pressure measuring device, or we can say the device which is used for the calibration of the pressure measuring devices, known as the deadweight tester. We studied its working principle. We studied that why it is known as a deadweight tester. We studied its construction, its applications, advantages, and its limitations. So I hope that this topic is now clear to you. Thank you.